Welcome, everyone. My name is Bruno Kopreski. Currently, I'm the lab director here at iGenomics Brazil. I'm working with PGTA, PGTM, PGTSR since 2013. It's been a long ride, and it's a pleasure to me be here with you guys and talking about mosaicism with such a great name and see what we can see about the mosaicism until right now and to hear about everything that Manuel is doing. So this scientific webinar is with a proposal to introduce and to discuss the International Register for Mosaic Embryos Transferred and how your clinic or your laboratory can be part of it. It's supposed to be just a local webinar here in Brazil, and this is why I'm just going to say a few words in Portuguese. Boa noite, pessoal. Tudo bem? Mais uma vez, eu queria agradecer a todos pela presença. Para a gente é um prazer organizar esse webinar, que deveria ser um webinar brasileiro, com o Manuel Viotti, mas o interesse do mundo inteiro foi tão grande e a gente trouxe esse webinar para um nível global. Eu gostaria de agradecer a todos, a presença de todos, e quero que vocês aproveitem muito. Well, getting back to English again. So it raised a great interest, and today we have people from all around the world, such as Japan, Europe, India, and of course Brazil and United States. And I want to like to thank everyone for the interest and to be a part of it. And for that, we've also invited Alicia Snyder to join me as a moderator here in this webinar. Alicia Snyder, currently it's our VIP for clinical genetic service at iGenomics United States, has one of the greatest mind of genetic counseling here in iGenomics in all the entire world. And I would like to thank you, Alicia, a lot to be part of this webinar. It's such a pleasure here to myself and to iGenomics to have you on board. And for this talk, we invited Dr. Manuel Viotti. He is the Vice President of PGT and Clinical Laboratory Director at King Labs, KinBody. He also holds an appointment as Senior Scientist at the Zoves Foundation for Reproductive Medicine. He obtained a PhD in Molecular and Cell Biology from Weill Graduate School of Cornell University in 2022, studying mammalian development biology. Dr. Viotti then completed a postdoctoral fellowship at the biotech company Genentech, investigating human cell dynamics and differentiation. His current research aims to improve outcomes in IVF clinic with a special focus on molecular and cell biology of the embryo and uterine envelopment. Dr. Viotti, before you started, I would like to invite our guests during this webinar to use the chat and to send your questions and consideration. Alicia, would you like to say some words before Dr. Viotti to start?
Thank you, Bruno. Thanks for that introduction, and I'm very excited to be participating in this webinar with Manuel today. I'm pretty excited about the content, as I'm sure many people are. As Bruno said, this wasn't originally intended on being a Brazilian webinar, so we had a lot of interest internationally, including a lot of people from the United States. So that's why I've been added on just a few days ago to try and support the US perspective or the international perspective, just in case anything needs to be clarified, since the iGenomics affiliates are a little bit different. So with that, I'll go ahead and hand the mic over to Manuel Viotti, and we're looking forward to what you have to share.
Thank you both. In a way, I'm happy that this was kind of expanded and it's now in English, because I was initially asked to maybe give it in Spanish or even Portuguese, and I was like trying to like brush up and all that, but in English it'll come easier to me. But okay, let me start the slides here. So thank you so much again. Let me just minimize some windows here. Okay, so this again, thank you. And this talk is there's obviously many aspects, many angles you can talk about mosaicism in PGTA. But here I'm going to focus, not talk too much about the biology of it or the technical aspects of it, on which a lot has been already been debated, and those conversations will continue, obviously. Here I'm going to focus on this, on the clinical outcomes of the embryos that are classified as mosaic with PGTA, and specifically talk about this effort that we're calling the International Registry of Mosaic Embryo Transfers, IRMT for short. We already have an acronym, and the idea is really to just collect data from centers and labs that want to participate and have clinical outcomes for mosaic embryo transfers. And the goal is really to find trends and find correlations of what traits of mosaicism influence clinical outcomes, so that we can prospectively manage embryos better in the clinic based on data, retrospective data, and the lessons we've learned from large data from different centers. So I just want to start by saying this: we are all mosaics. So every person watching this webinar right now is mosaic. Mosaicism just means that an entity, a body, has two different cell lines with different chromosomal content. And this is just to demystify a little bit the concept of chromosomal mosaicism, because sometimes it's kind of looked at as the boogeyman or something, but it's actually quite a natural phenomenon in human biology, but in all animal biology, and in fact throughout nature. If you consider, for example, here's three examples that might make you think a little bit about this. Is it's known that about 30 to 40% of cells in normal human brains with normal function are aneuploid. About 25 to 50% of hepatocytes in healthy adult livers are aneuploid as well. And there's another example is this phenomenon known as mosaic loss of Y, where as males age, they start losing the Y chromosome in a percentage of cells. So if you look at 70, and that correlates with age. So if you looked at 70-year-old male, any 70-year-old male has a 40% chance of having mosaicism in chromosome Y in their leukocytes. And it's also correlated with smoking. So if you're a smoking 70-year-old male, you have a really high chance of having mosaicism of chromosome Y in your blood cells, in your blood cell line. So in a way, mosaicism, chromosomal mosaicism, is really the normal state of affairs in human biology, human physiology. However, as we know, there's also pathogenic mosaicism, and many constitutive aneuploidies that lead to mosaic, that lead to, for example, Down syndrome or Klinefelter syndrome, also can exist in a mosaic situation. There's also others, Pallister-Killian mosaic syndrome, and many more. So the question is, when does it become pathogenic, or when is it harmless? And there we get into the nitty-gritty. There's many permutations of how mosaicism can exist in the human body. What tissue is affected, what organ is affected, what's the percentage of cells that are aneuploid, what aneuploidy is involved. And maybe to this crowd, what's most interesting is, in development, when does mosaicism become established? Because you can imagine, if mosaicism only becomes established in a fully adult body, maybe the aneuploid cells are very targeted to that tissue, to that organ. On the other hand, if the mitotic error that gives rise to mosaicism happens early on in development, then, for example, a larger percentage of cells in the final body will have that aneuploidy, and a higher chance of that aneuploidy to cause physiological consequences and have medical consequences. On the other hand, there's something interesting called self-correction, which a lot's been talked about as well. But in the context of mosaicism, at least, that means that there's a competitive advantage of euploid cells, so that the aneuploid cell compartment could disappear over time just because that compartment proliferates less rapidly or undergoes targeted apoptosis. So there's a lot of dynamic, it's a very plastic system. There's a lot of forces at play. However, it's something we have to deal with. We have to deal with in PGTA because, as you know, we take a multicellular biopsy these days, or most of PGTA is based on multicellular biopsies. If all cells are euploid, that's very easy then to diagnose. If all are aneuploid as well, but then since mosaicism exists, and that's in embryos, that's been documented for over 30 years now. Once in a while, we will come across this situation here where we collect a mix of euploid and aneuploid cells in the biopsy, and that's then the result that we get from the reference lab or the in-house PGTA lab. And what do we do with that? What do we do with that? What happens when you transfer a mosaic embryo? So the first study that reported really the prospective transfer of embryos that were classified as mosaic was this one here from Greco and his colleagues from 2015, where they transferred 18 embryos that were classified as mosaic, and they actually resulted in 6 pregnancies that were apparently healthy. Prior to that, the stance was really to lump or group the mosaic or embryos with mosaic results with the uniform aneuploid embryos and just into an abnormal category and not consider them for transfer. However, then this opened the floodgates a little bit because this gave patients that didn't have any euploid embryos new hope, a new perspective that maybe they could consider those that had mosaic results. And quickly after this, many labs started considering the transfer of mosaic embryos, resulting in several papers, several studies with different sample sizes, technologies that were used. There was a lot of heterogeneity here, and so data was trickling in kind of into the field without any clear centralized method to analyze the data. And that's the moment that gave rise about 2019 or 2020 to this effort that we're calling the International Registry of Mosaic Embryo Transfers. This is really a grassroots started organization by just a couple of centers that said, hey, we're all publishing our little studies, and that's important too. I mean, it's obviously important to look at your specific center and see how those embryos behave in your center. That's for sure important. However, to do some of the analyses we wanted to do, we really needed larger numbers, higher power of analysis, and so we just got together, started, comparing data, mixing the data together, and doing that kind of analysis. So the goal of this registry is really to have one centralized database of embryos that were classified as mosaic and look at their clinical outcomes. And like I said before, trying to learn from the trends that we see in order to, going forward, better manage those embryos and choose the embryos and rank the embryos accordingly by the ones that have highest chance of leading to a healthy take-home baby. We wanted to really determine the clinical success rates of embryos classified as mosaic, but not only that, but also identify features of mosaicism that can be learned with PGTA and see if they correlated with clinical outcomes. And obviously also understand the risk to the pregnancy of a mosaic embryo transfer. And for that, we started, I'll talk about this a little later, we started collecting more and more also prenatal testing data that was related with mosaic embryo transfers, as you will see. These are the 4 people that are kind of in the inner office, if you will, of the registry. We, if you don't know them, Francesca is in Rome. She's in Eurofins. Svetlana is in Toronto to create, and Andrea is a genetic counselor with NYU Langone. And we were the early kind of participants in this effort, and we meet regularly, discuss what is the best kind of data to collect from labs, from clinics that want to participate. Obviously, we're always playing that fine line of how much data to collect that is relevant, but not too much data that we make that effort impossible and nobody wants to contribute. So we've modified the data we collect over time, and we're refining it and so on and so forth. So when we reached 1,000 mosaic embryos, we published our results, and that culminated in this paper here. But obviously we wanted to continue because there's lots and lots more. We can refine our findings. We can do many sub-analyses that haven't been done yet because we still didn't have enough numbers. And in fact, if you think about how many subcategories of mosaicism can exist, or if you could do it even by chromosome, mosaic trisomy 18, mosaic monosomy 1, to understand each one of these chromosomes, each one of the segmental regions that could be involved in mosaicism, which is really unlimited. The number of samples you need becomes astronomical, and so that's why we need to continue collecting data and seeing new trends, more trends, and that's why we need to continue this effort. These are the centers that are actively contributing now. We have at this point just over 2,700 mosaic embryo transfers, and we have pretty detailed data with metrics of the babies that are born from about just over 630 mosaic embryo transfers, and we have 510 prenatal testing results related to those mosaic embryo transfers. So this is growing every day. Right now, I'll show you some results that these are not new. This is not new data. So this was already presented last year, for example, at the ASRM. But it will give you a flavor of what kind of data, what kind of information we can glean from this effort. So here's when we compare. So on the x-axis we have ongoing pregnancy. So this is the euploid control group. We have about a 50% ongoing pregnancy, and when we compare that to the ongoing pregnancy rates of all the mosaic embryos, and you can see here we have 1,700. I just told you we have more than that. We have 2,700, but like I said, this is an intermediate analysis that I'm presenting here. We had, those mosaics have lower ongoing pregnancy rates than the euploid control group. And then when we look at only mosaic embryos that involved whole chromosomes, so excluding all the segmental mosaics, these differences are even more pronounced. If we look at spontaneous abortion rate, so that's any embryo that implanted, so that had a gestational sac, but then the pregnancy got lost along the way. So either very early on or later after fetal heartbeat, all of that counts. We're counting as a spontaneous abortion. The rates of spontaneous abortions are much higher in embryos that had been classified as mosaic. Now, okay, one big aspect of this is obviously we want to do a fair comparison, and we want to exclude the possibility that confounding factors are really responsible for these differences that we see in ongoing pregnancies between the groups. For example, one thing could be, well, maybe the patient population is different, and it's not really the mosaicism in the embryo that's creating these differences, but it's really the patients that are receiving mosaic embryos during their transfers are poor prognosis patients, and that's why we see lower ongoing pregnancies and more spontaneous abortions. So because we're collecting data, and we can collect any type of data, we're collecting information on the patients. What was their history? What is their why are they undergoing PGTA? Is there a history of repeat implantation failure or repeat miscarriage? So if we then compare if we compare euploid embryos to mosaic embryos that were going specifically into patients that were good prognosis, so no history of repeat implantation failure, no history of repeat miscarriage, the differences are still there and in a significant way. So telling us that it's not the patient population that is different causing these differences, it's really something embryo related. As another example, the morphology of the embryo could be different, and that's why, for example, the mosaic embryos could be on average much poorer morphology, and that was causing the differences. But when we control for morphology, we see that the differences still persist. And for example, we can also do this kind of analysis where we looked at only mosaic embryos where there was no knowledge of mosaicism at the time of transfer by the physician. So they were treated just like euploid embryos. And there still we see a difference. Although here note that the sample size is very small, because now we've basically stopped collecting these embryos because everybody wants to know about the mosaic state. So it's hard to get data on embryos that, with no knowledge of mosaicism. Another thing is, like I mentioned, the features of mosaicism and how they affect clinical outcomes. And there's two pieces of information we can learn from PGTA. One is the mosaic level, which is basically the percent of cells that are aneuploid in the biopsy, and the other one is what aneuploidy is involved. Is it a segmental, 1 or 2 whole chromosomes, or complex, more than 2 chromosomes? And what we see is when we plot the data by the different subgroups, by the different permutations of these two factors, we see that some subgroups perform much better than others. So for example, those high mosaic embryos with complex mosaicism have the worst outcomes. And on the other side of the spectrum, you have the segmental mosaics. They do quite well. However, in our data set, at least, even those still perform worse than the euploid control group. So it would still make sense, all else being equal, morphology being equal, to prioritize a euploid embryo transfer over a low mosaic segmental embryo. But here I just touched upon another point, because when we rank embryos or when we prioritize embryos, we also take morphology into account, and it's not just the results of PGTA. So it became more, the analysis becomes more complicated, but basically what we did is looked at our database and created a matrix resulting in this kind of embryo score calculator and this is freely available, by the way, if you want to try it out, where you select the subgroup, the subtype of mosaicism of any embryo, and you select the morphological parameters based on the Gardner grading system using pull-down menus, and that results in a score, and this score can then be compared between embryos in a cohort, in a cycle, to be able to prioritize them according to chances of success based on real data that is part of the registry, based on historical data of the registry. So this is not 100% for sure. That you can never tell if an embryo will for sure implant or one will for sure miscarry or whatever, but it's just trends that are learned from the big data that exists and help us rank embryos going forward in the clinic. Okay, now about newborn data. If we compare the weight at birth of mosaic embryo, of the babies born from mosaic embryo transfers, they're pretty much the same as the one born from euploid embryo transfers. Same thing goes for length of gestation. So these are two metrics of basically health of the baby at birth, and we see the same numbers overall. between babies born from mosaic embryo transfers or euploid embryo transfers. Also, in the 415 babies that were born, we see no gross abnormalities as defined by the CDC. So there's a strict, defined list of what defines a gross abnormality, and in none of them there was one. So overall, what we're seeing is, at least from these metrics, is that the babies born from mosaic embryo transfers are really indistinguishable from those born from euploid embryo transfers. So there's a bit of a disconnect here, because on one hand, we're seeing lower implantation rates, higher miscarriage rates with mosaic embryo transfers. And however, though, if the pregnancy continues, then by the time that those babies are born, they're indistinguishable from the babies born from euploid embryo transfers. And we think that has to do with, I briefly touched on this, those self-corrective mechanisms that are at play. And here I really want to point out, there's a bit of confusion there. Like, by self-corrective mechanisms, it's not that we're talking here about an aneuploid cell becoming a euploid cell through an aneuploid rescue. We're talking in a context of aneuploid and euploid cells mixtures, the euploid cells outcompeting the aneuploid cells, so that in a way the whole entity corrects itself. The mosaicism disappears because the aneuploid cells are diluted out, or they become so confined and that they're clinically irrelevant. However, though, if we look at prenatal testing data, we can then see what happens to the chromosomal, if that self-corrective mechanism, those self-corrections actually are happening or not. And like I said, we have over 500 pregnancies from mosaic embryo transfers that have corresponding prenatal testing or products of conception data in our database. And in the vast majority of cases, the prenatal testing is normal when in a mosaic embryo transfer. Suggesting again, like I just said, that this mosaicism might be corrected along the way. In 5 cases, though, we saw the same mosaicism that was present during PGTA show up again during prenatal testing. So in these cases, it appears that those self-correction mechanisms did not take place. So it's not 100% efficient. It's only 5 cases out of 500, so we're talking about a 1% time, but that poses a risk to the embryo, to the fetus, to the pregnancy, and potentially even to the patient. These are the 5 cases. So this is the original PGTA result. So for example, if we take this one, there was a trisomy 21 mosaicism, low level in PGTA, and then that shows up again in CVS and in amniocentesis. And, in ultrasound, they see anomalies during the pregnancy, and that pregnancy spontaneously aborted. Another case, for example, is this one, where it's a segmental low-level mosaic result during PGTA, and that same mosaicism of that same segmental region is observed in amniocentesis and again in the products of conception, and so on and so forth. So 5 cases in total. That is to say that the risk is not 0. So transferring a mosaic embryo, although the chance of this is very, very low, the risk is not 0. The risk is not the same as a euploid embryo transfer. Now, here we got into a different discussion, because when you transfer a euploid embryo, sometimes you also get miscarriages and you also get mosaicism during prenatal testing. However, that baseline mosaicism is probably happening in both populations, but on top of it, in the mosaic embryo population, you also have those cases where the original mosaicism persists throughout the pregnancy, and those are these 5 cases here. This adds to the one report that has been published a couple of years ago from the group from Semra Karaman in Turkey, where they actually saw the mosaicism persist from the PGTA phase all the way to birth of the baby, and they saw the mosaicism in the baby in blood, I think in blood and buccal swabs, or one or the other, but the baby luckily was healthy or didn't have a phenotype. Okay, so from the registry so far, the data indicates that the mosaic group performs differently to the euploid group, obviously performs differently to the aneuploid group. I mean, by now there's several studies showing that embryos with uniform aneuploid results barely ever, result in a birth, and if it does, it's a baby that suffers from some syndrome. And within the mosaic group, there's parameters or features of mosaicism that can be used to rank and prioritize embryos. And then the babies born from mosaic embryo transfers seem to be healthy. And this means that, and that coupled with the prenatal testing results, mosaicism resolves itself during pregnancy with few exceptions in about 1% of cases so far. That's what we're seeing from our data. Now back to the registry itself. This is kind of a map of centers that are contributing in red. Orange are the ones that have recently joined that are collecting data. So it's really expanding. I like to say it's present in every continent. We're missing Africa, so if there's an African clinic out there, it would be awesome to have you join as well. Antarctica, we're not going to talk about, but it's growing. It's a growing effort. But why? Some updates, some things that we've changed recently about this registry is that we're accepting data from all platforms of PGTA, and that's important because we'll be able to then compare and contrast how different platforms, behave. We're trying to pinpoint the thresholds of mosaicism that are most appropriate. And however, I can tell you so far that from the platforms that have contributed, the overall trends hold throughout the platforms. We're collecting a lot of information on variables and potential confounders to really confirm that the trends we're seeing are not due to some, artifact, but really due to the mosaicism that is detected with PGTA. And we're collecting data quality metrics. Again, there's discussion about noise, whether noise in the results can be interpreted as mosaicism. And if you're not careful, it can, but that's why we're following up on that and trying to make sure that, again, that the results we're seeing are real and not due to some artifact. But then why contribute? Why go through the effort of contributing to this registry? So some insights can only be learned from big data. I mentioned this briefly before. There's many sub-analyses that we cannot even perform yet just because we don't have enough representatives of each subgroup and every chromosome being present. Again, obviously it makes sense that every center does their own analysis, internal analysis, but at the same time, you can contribute that data to this effort and we can have like more global analyses and more global trends being analyzed. We want to look at difference between platforms, between thresholds, see what works best. At the end of the day, we want to really, figure out what's best for the patient, what's the best way to rank embryos so that there's a highest chance of success. And I just want to stress, this is really a collaborative effort. It's almost academic in a way. There's no, to my knowledge, like financial or commercial drive. If the data starts showing or showed that there's no difference between any groups or whatever the data shows is what it shows. I don't have a bias. I think we just want to learn really what's going on and then how to best serve the patient at the end of the day. And it's a collaborative effort with real world impact. I mean, many clinics are starting to use this, and that's something we want to follow up on as well, seeing if starting to implement these ranking systems improves clinical outcomes over time prospectively. People that, the centers that collaborate, they have free access to all the data. So one thing we're seeing is that what happens sometimes is like, they want to know, oh, I have a patient with a high mosaic trisomy 18. What is the data on that? So we can look at the whole database, see how many have been transferred, what is their clinical outcome, and so that's also real world impact. And a lot of this we're seeing recently. So that's a good use of this database as well. Whereas if you just use your internal history, sample size of those are likely very small, and you cannot make very educated guesses from that. If your center would like to contribute or participate, basically this works. Since this started really as a grassroots thing, we're working with Excel sheets where we send you, this template Excel sheet that has columns, and you can imagine, it has information on what the mosaicism was for that embryo, what was the level of mosaicism, what type of mosaicism, and what was the clinical outcome. Was it a birth, or was it a biochemical pregnancy, ongoing pregnancy, and so forth. So there's several columns here in the Excel sheet, and you start filling one by one, and then when you're ready, you submit, and we work together. We add that to the overall database, make it uniform, and then it's part of the bigger analysis. If you're interested, here's the email address that you can contact us with. QR code if you want to have it on your phone. But yeah, just shoot us an email and we will happily, onboard you. So with that, I need to thank, this is getting bigger and bigger. The font is getting smaller, but the different centers and the main contact people inside of each center. And it's a lot of back and forth, a lot of emails and phone calls. In a way, it's a lot of fun, it's a lot of work, but I think at the end of the day, it's data that is really applicable and we can use in the clinic. So I really want to thank all these people for all their effort and in this journey. So so with that, I want to conclude and send it back to the studio for Q&A.
Dr. Manuel, thank you so much for your brilliant presentation, for all the data showed us. It was amazing to see every aspect of it. We have until now such a few questions, but I would like to open the mic to Alicia if she has any question to present to you, and then we start with our Q&A question from the audience. Please, Alicia.
Thanks, Bruno. I have lots of questions, mostly out of curiosity, but there is a question from our audience, so I think we can go ahead and start with that. Do you want me to read it?
No, I can do it, and then we can share. So the first one was from Aline. I know Aline, she's from Brazil. And is there any data available on placental mosaicism tissue analysis after birth? After baby birth, I'm sorry.
Right. So we have actually very little after birth analysis. Unfortunately, it's very hard to collect that data. We're trying, we keep pushing, we're trying our best. That's a little bit what's missing. We can get all those metrics of the babies when they're born, weight, gestational length, but really to do a full, to get buccal swabs or placenta or anything on after birth, it's very, very hard. We're finding. What we do have is that intermediate snapshot of the prenatal testing results. And again, there's a lot of mosaicism is messy. There is sampling error or sample bias there, but overall, what we're seeing is that mosaicism is being resolved, even when we looked at CVS or NIPT, which does collect data from, or a sample from the placenta. So my guess is that by the time that baby is born, that original mosaicism from the embryo, it's very unlikely that it persists to the placenta because of the CVS and NIPT results that we're getting. But that's a good question. Yeah, I would love to get more data on the babies that are born. It's just very hard.
Has there been any discussion about an additional IRB? So it sounds like the inclusion of the data into a registry is routine clinical practice, so no IRB is needed for that per se. But if a patient wanted to undergo an IRB and have this placental testing occur after birth, is that something that's being discussed at all, or not in the scope of what you're working on?
No, we would love that.
Yeah.
In fact, I mean, I don't want to say we don't have any of that data. There is some data on that, on the babies that are born, and you know, we're basically collecting everything we can get on that. There isn't a, so for the purpose of publication and analysis, there's an IRB, and then each clinic and center, because it varies a lot on region, some of them have procured their own IRB according to their situation. So we're, it really depends a bit on where the clinic sits and so on. But yeah, we're trying to basically collect as much as possible.
Yeah. Want to read the next question, Bruno?
Yeah, so moving on. It's a question from Roger. A recent study by Bardos and colleagues in fertility sterility showed that there can be significant difference between reference labs. Of the many variables between reference lab, one of the conclusions was that not all the NGS platforms for PGTA are the same. How do you account for the how do you account for that as you expand the scope of this study? For example, low-level mosaic on one platform may not be a low-level mosaic on another.
That's absolutely, yeah, that's a great question. I mean, in a way, the beauty of this is that we can, when we get data, it comes together with that data. So what platform was used, what thresholds were used to define a mosaic result. And so when we can obviously do a global analysis of how the mosaics performed compared to the euploids or something like that. But then one sub-analysis we can do is like, okay, if this platform was used or that platform was used, what did the clinical outcomes look like? If this threshold was used or that threshold was used, what did the clinical outcomes look like? So it's definitely true that there's variability, but what we're seeing is that at least of the platforms that have contributed so far, and those are all whole genome amplification based next-gen sequencing PGTA. There isn't a lot of variability within the platforms, and the overall trends are persistent. What changes more is what thresholds you use to define the mosaicism, and that's where we're really trying to find out what's the most appropriate threshold. And that you can conceptualize, you can theorize, but the best way to do that is just with existing data and see, well, if you apply this threshold, what kind of outcomes do we get? And now reanalyze the whole thing, but using these thresholds, and then see if we get better clinical outcomes or worse or so far. There's always because are we grouping according to what thresholds you use? Are you misclassifying those that should be truly intermediate copy number, truly mosaic? Are you misclassifying them with the aneuploids or with the euploids? So it's a fine balance you're playing, but since you can run the analysis with different thresholds, we have the data on the mosaic level for every embryo. So we can do this iteratively and find the best threshold that should be used, even specific to which platform. So that's definitely a really important question. There is variability amongst platforms, and something that we're really looking into.
And Manuel, let me just ask you something regarding the threshold that you are using. So far, you're using 20% of to start a mosaicism. So 20 to 15 is a low grade mosaicism, and 50 to 80 you're considering high grade mosaicism.
Again, it varies by clinic now. You know, in the initial study that we published in 2021, we all use the same platform with the same thresholds. But now we're getting data coming in from a clinic that uses 30 to 70. Another one uses the same platform as we had before, but with a different threshold, or a different platform with the original thresholds of 20 to 80. So all these permutations we'll be able to do sub-analyses on. You know, a big part of it is to obviously validate the platform in your hands, or if you're not running PGTA in-house, to look at the validation of those platforms that is used for your PGTA reference lab. But again, what I'm seeing overall is that the platform itself is not the main contributor in differences. It's more like the thresholds that are being used. And I think it's still to be revealed what the most appropriate threshold is. The 20 to 80 was originally proposed, well, originally by Santi Monet in his papers. Then it was kind of adopted by PGDIS or promoted, and it made conceptual sense as well. So if you have 5 cells in a biopsy, you know, if one cell is aneuploid, you're already picking that mosaicism up. It's at the 20% mark. Anything under that is noise, or at the 80%, same thing. However, I think there's going to be a lot of data coming out soon on embryos that are at the intermediate copy number right around the 80 to 70%. How many of those are truly mosaic, and how many of those are actually aneuploids that are just noisier? And we'll be refining that over time. Well, I mean, this is a field that is growing. You know, data is being added. It's a really dynamic field. At the same time, all the clinics are trying to figure out, okay, which embryos, what thresholds do we use? So it is, but the beauty of it's self-corrective, and it will be refined over time. But to your specific question, what thresholds am I using, or are we using? I don't want to give you a specific answer. It's a dynamic topic.
You said, Manuel, that you could do iterative reanalysis. So are you having all participating centers trying to provide an exact level of percentage, which is, to be honest, really imperfect? So if we see 35% level of mosaicism, that doesn't tell us exactly how many cells are euploid or aneuploid. That's a bioinformatics analysis of the average copy number variation, which is quite imperfect, and we're not providing that to our clients. So are you asking your participating centers to provide that figure to you?
If they can, we are. And I with the full understanding that it's not, you know, some clinics are, or some centers are even providing numbers like 31% aneuploidy, and that's just, you know, impossible, biologically impossible. But still, it's like the best approximation that there is, you know. When you look at big data, hopefully those, I mean, it's not a perfect system. We have to, but it's not a perfect system technologically and biologically. You know, however, we have to make do with what we can, and do best we can. You know, to me, I always say this, it's even conceptually, it's weird that a mosaic embryo with low-level mosaicism performs better than a mosaic embryo with high-level mosaicism, just conceptually, because, as you know, if you take one biopsy from one side of the embryo and you take one from another side in a mosaic embryo, many times they won't be concordant, many times. So why is it that one where the original biopsy was low-level mosaicism, does it perform worse? You know, but the data is just showing us that in large data sets, on average, one with the original, low-level mosaicism performs better than the high-level mosaicism. So why exactly that is, I don't know. But from a clinical standpoint, it makes sense that we use that knowledge, those trends. And it would be unwise not to use those trends. But it is a messy system. I do agree, but we have to try to tackle it best we can.
I have heard the call for uniformity between laboratories. In your mind, is that the ideal outcome of this registry, is to find the perfect thresholds and to bring the laboratories together and have uniform thresholds?
I don't know. I mean, yeah, it's almost like utopia thinking, but I wish there was. I wish, like, over time with more data and confirming what the trends we're seeing, we narrowed down and really pinpoint what is the threshold where really embryos with results in that intermediate copy number are truly mosaic. So where the biopsy had really aneuploid and euploid cells. To do that to really confirm that, you need to do other analyses based on SNPs to really determine whether that whether that error was mitotic or meiotic in origin. So I think those are the studies we're missing, and my suspicion is there's some in the works, which is good, and they will help us determine or better define those thresholds. It would be nice if eventually there was like a universal threshold and a universal platform that we could define. I don't know if we'll ever get there, but at least we can approximate it. We can do it best we can, get as close as possible. I don't think it will ever be, the biology of it is too messy for it to ever be perfect, But same thing with PGTA in general, A euploid embryo will not necessarily 100% implant 100% of the time.
Right.
It's just a ranking system at the end of the day. It's a prioritization system.
We have more questions from our audience. Bruno, do you want to read the next one?
Yeah, we do. Carlos sent to us, what would be the recommended prenatal testing for the mosaic embryo transfer follow-up, invasive or non-invasive?
Great question. Right, so by non-invasive, the typical NIPT or NIPS really probes mostly placental cells. So, and amniocentesis probes mostly fetal cells. What we're seeing from our data is that amniocentesis by microarray is the one that is most likely to capture the mosaicism if it persists. So in some cases, because we have that, like cases where you take CVS or NIPT and you take amniocentesis, and there's concordance in the mosaicism. So some NIPT versions now can even tell mosaicism. And so that happens. You have to be careful, like, okay, a lot of NIPT only looks at specific chromosomes. Is it really capturing the chromosome that was mosaic at the PGTA? And you have to keep that in mind. I think what we're seeing is really that amniocentesis by microarray is the most likely one to capture that mosaicism again. And if you want to be cautious, I think that's the way to go right now. Again, with the caveat that this persistence of mosaicism appears to only happen 1% of the time. So that goes all into play into the risk benefit of these prenatal tests that have their own risks, as we know.
Just to add to that too, from a patient perspective, obviously there's different risks for invasive versus non-invasive testing. So from a research perspective, of course, like the best test to do would be something that samples fetal tissue and looks at all chromosomes. From a recommendations perspective, we get this question a lot in the United States of what should I be recommending to patients? And the answer that I wish we would provide is, well, from a scientific perspective, we would like this information. From a genetic counseling perspective, we recommend that you discuss the pros and cons of the different types of tests so that patients can make good decisions for their own bodies.
That makes sense. Yeah, prenatal testing, it's almost like a give and take, you know. Non-invasive is the least risky, but it doesn't provide you information on true fetal mosaicism.
Yeah.
So it's a risk-benefit kind of analysis.
Do you want to read the next question, Bruno?
We do have a question from our Vice President of Sales and Marketing in the United States, Juliana. Juliana, thank you so much for your question. And Juliana asked us, with such a heterogeneous data, how it should be presented to be clinically relevant in an article?
Yeah, I mean, we have to, in an article with different platforms, with different thresholds, there would be a lot of sub-analyses, you know, showing, okay, now if we compare the mosaic outcomes using this platform, and this platform, this threshold, and this threshold. Are the commonalities, are they completely different? Which I don't think there will be. I think there will be many commonalities across the board. But yeah, that's a big thing that we will have to, you know, analyze going forward, and that we want to analyze and learn from going forward, the differences in platforms and thresholds, like we said. You can obviously do a global analysis of everything and see what you get, but yeah, the devil will be in the detail, you know. And it's a good question, and that paper, whenever it gets written, is going to be a lot of figures and a lot of sub-analysis, sub-groupings, and that's okay.
Yeah, you mentioned that, you know, this was going to be a collaborative effort, and the ideal outcome is whatever is best for patients, and I fully stand by that. And I think Juliana's expressing some concern, which I have too, that if you separate out the laboratories, that it's going to be a paper that compares laboratories, and it's going to have a pretty heavy commercial slant. Do you have an idea how to address that?
You know, my goal is, I mean, personally, I don't have a commercial bias either way. Like, say, for example, platform X shows always that mosaics perform exactly like euploids, and platforms Y and YZ show that they don't. If that's what the data is showing, okay, that's what it shows. We would publish that, and then the secondary question is, okay, why are these differences happening? Is, you know, if there is a difference in clinical outcomes between mosaics and euploids, you know, it will only become apparent if the technology can actually differentiate between the two. If it cannot, then for sure you will not see differences in outcomes. So, but that's the truth we're trying to get at. I mean, you know, in a way, it's nice that this is non-commercial. It's kind of, in a way, a watchdog of what's happening, because a lot of the times, you know, a lot of papers come out from reference labs, and it's really hard sometimes, you know, there's always, does it have to be taken with a grain of salt because there's a commercial bias or not? Can we believe this data? And then sometimes the analysis is done by a independent lab, and it can confirm the data or it can, you know, refute the data. Here, at least my goal, or our goal of the you know, the committee, is to keep it as commercially unbiased as possible. Whatever data comes out, that's what it is.
Right.
If, you know, if a center doesn't want to participate because of that, then it's their prerogative. I mean, it's their choice.
I do have another comment about the viable trisomies. So I know that the data that we have so far is not necessarily powered to say that there's a higher risk for mosaic viable trisomies, but I was really struck by the list of cases that you had where mosaicism was persisting, and to see 2 of them involving mosaicism of trisomy 21. So I'm kind of curious to hear your thoughts on that, and if you imagine that this big data registry that we're moving forward with will really help clarify the risk for the viable trisomies specifically. I feel like we've kind of whiplashed from all mosaics are dangerous, never transfer them, to all mosaics have low risk, go ahead and transfer them, to now I'm looking at your data like there's a few viable trisomies in that list, and should we be concerned?
And in fact, if you think of the really early days, conceptually people were saying, oh, maybe trisomy 21, 18, and 13 we should avoid. Mosaic trisomy 21, 13, 18 we should avoid, because they have the highest chance of persisting, obviously, and the highest chance of having some clinical effect. Then, people moved away from this a little bit, but like you said, what the data seems to be showing is that at least in 2 cases, the trisomy 21 persists, and it might be that the original hypothesizing, strategy actually was right. I don't know. It's still early days. That's a problem. It's still, the sample size is still too small to really make those calls.
Yeah.
And that's why we need to expand this data set. We need to have more and more and look at big data. But those things will crystallize out. That's the goal. Those key information should come out of that big data.
Yeah, that's one of the things I'm most looking forward to.
If consistently, in prenatal testing data, mosaic trisomy 21, 18, 13 are the ones that we're seeing, then then that's it. Maybe then for sure we should avoid those. Or we don't see that. It's like random. So then what do you do? Yeah, it's all, the data will tell, really.
Alicia, do you have any other question?
There's a couple more questions from our audience. If you go back, I think we skipped one from Kamal Lighting.
Oh.
Do you want me to read that one?
Yeah. She said, "Hi, Manuel. This is a really good job, and you encouraged most of us in the part of the world. My question is, I see you have data already on different mosaic embryos. Can you share?" Didn't get that question quite well. I think Manuel has already showed the data that he has, and we are looking for more data, right?
Yeah.
Regarding the data, I do have a question. So in the previous publication and all the data that you have said and showed us, you didn't show us the difference between the chromosomes that we are seeing. Have you have any maybe a glimpse or something like you can show us, or you can say to us, like, have you seen difference between the chromosomes 21 or 10 or something like this? Because we do have our data here at iGenomics, and we can see that we have more frequent mosaics from chromosome 16 and everything. Do you have such a data that we say, for instance, we have seen in other publications? Do you guys pretended to show this type of data as well?
Yeah, but again, this registry is only for mosaic embryos that have been transferred. We're not looking at, we're not cataloging what's the most common type of mosaicism seen in the embryo. We're just looking at those that were actually transferred. So we still don't have enough per chromosome to make any significant correlations. We simply don't, and that's why this is a call for people to contribute.
Yeah, perfect.
Their data.
Yeah, this is the most important part of it. This to keep every single one and all the clinics that are here at this webinar. We really encourage everyone to present the data, to show the data, because this is going to be super inspired for every scientific aspect of it.
the way I envision it, you know, because we were discussing this a little bit before, some of the centers that are part of this registry right now have, you know, an in-house, it's a clinic with in-house PGTA, and then so they have all the data under one roof. And however, another model that some clinics have, or centers have been using, is that they collaborate with their reference lab, and together they submit data that has, you know, the genetic testing results and the information on the genetic testing, and then the information on the embryology coming from the clinic. So these collaborations are happening, and I assume iGenomics would be interested if a clinic submits to iGenomics their embryos, collaborating with those, like setting up those collaborations to then contribute to this registry if they're interested. What we're seeing is that starting this formal data entry system in that Excel sheet that I briefly showed, you know, is that it's what's becoming also their internal Mosaic data collection system that they then do their internal analysis with, because we've put our minds together to really come up with the most important and relevant information that is needed to really collect the data and collect the information on confounding factors. So it's then used internally for their own sake, but then is also easily then transferable to contribute to this bigger effort.
That was my last question, is there any concern about duplicating an entry? So I know that some of these larger networks, you know, maybe it's not just one clinic, but it's a larger network, and they might contribute data for their network and then also contribute data to your registry. Is there any concern about duplication that way?
So we've had to, in one case, really go fine comb through the data and really make sure that didn't happen. You know, it's what really hasn't been happening so far is that a big reference lab just sends us data that then a clinic could also send independently. Usually it's like I said, like together, they work together and come up with that information that is sent to us. But there is a point we have to contest, or I don't know what the word is, fight with at some point. And it's a good point. Yeah, no, yeah, I think so. Right now, I can safely say all our data is unique, but going forward, that's definitely a point that needs to be taken into account. Yeah.
Well, this is a tremendous amount of work, and I'm so appreciative and amazed at all of the work that you've put into it and your collaborators. So thank you. I don't think I have any more questions.
Yeah, I would like to say a few words also. Thank you, Manuel, for incredible aspect of job of it is brilliant. I think we have to encourage our clinics like to be more participate more and more. We would like to also explain to everyone that is watching that this webinar will be recorded. Also, I'm going to say some few words in Portuguese to our clinics here in Brazil. Pessoal, nós gostaríamos, né, de realmente agradecer a todos que estão presentes aqui nesse webinar e realmente apresentar a ideia do Manuel, que ele trouxe tudo para a gente, e realmente dizer que a Genomics está à disposição para poder fornecer os dados, para a gente compartilhar esses dados e para a gente cada vez ter mais acesso às publicações com relação a Mosaic. Well, once again, unfortunately, we can spend like 2 hours, 3 hours talking about mosaicism, but unfortunately we should go. So once again, thank you, Manuel. It was a brilliant presentation. Thank you, Alicia. It was brilliant questions and brilliant presentation as well. And thank you all, and looking forward to see you as soon as possible.
Thank you.
Thank you so much.